Here we're going to consider the set model of addition with integers. I have another video in which I introduced the set model of addition and we were using only whole numbers. No negative numbers were involved, and here we're going to see what happens when we allow negative numbers as well. So just a quick review of the set model of addition. The way it works is that for each addend, you create a set representing that addend. So this is 3. I have 1, 2, 3. And then we also have 4. So I create a set representing that number, a set of 3 and a set of 4. Addition is push together. So we take these two sets and we push them together. We now have one new set and we count how many are there. 1, 2, 3, 4, 5, 6, 7. So 3 plus 4 is equal to 7. One of the reasons that I use these little chips from a set of algebra tiles is that they have one color on one side and one color on the other. So I choose one to be positive and one to be negative. We're going to use red to represent a negative number and white to represent positive 1. So moving on to our next example, -1 plus -2, we need to represent each of those addends, each of those numbers, with a set. So the red side of the chip represents -1, a single unit, single chip with the red side up is -1. And then I create a set for -2. As we know, addition is pushed together. So I'm going to push these sets together. And then we count up the result. The result is 1, 2, 3, but those are red, which represents negative. So the result of -1 plus -2 is -3. So in my first example, I had two positive numbers. In my second example, I had two negative numbers. So we had things that were alike being pushed together, white pushed to white, red pushed to red. But in our next two examples, we have a negative and a positive, so we have a mix of the types of numbers. So -2 plus 4, I represent the -2 with a set. Then I also create a set of positive 4. And when we push those together, something sort of different happens. I see that there are 6 chips there, but our answer isn't going to involve a chip. Because when you have a red and a white come together, you've got a -1 and a positive 1, and those zero out. That is known as a zero pair. I've got a zero pair here, a zero pair here, and then I have two positive ones. 2 plus 0 is just 2. And I can remove these zeros from the result. And I see that the answer to -2 plus 4 is positive 2. I'm going to go ahead and leave those there as I move on to our last example where we'll do -5 plus 1. So I create a set for the first addend, which is -5. For us, that will be 5 red. And then I create a set representing the positive 1, which will be 1 white. We push them together, and once again we see coincidentally here that we end up with 6 chips. But when you have a pair where you have 1 red and 1 white, in some sense those cancel out, or maybe it would be better for me to say that those zero out. -1 and positive 1 together, added together, pushed together, give us a 0. So we can actually remove those, because if you add 0 to anything, it is just the original thing that it was. So I notice that what I have left are 4 chips, and those are all negative. So the result here is -4. Notice that sometimes when you add negative and positive, numbers with different signs, sometimes the result comes out to be positive and sometimes the result comes out to be negative. And eventually you learn rules about things like looking at the absolute values of the numbers in order to determine before you begin the problem whether the result will be positive or negative. But the thing about using models in order to teach working with integers is that students can begin to see why it is that an answer here would come out to be positive and why an answer here would come out to be negative. And of course, you would want to do many examples, not just one example of each kind.